Hi, I'm Austin,
Hello, I'm Jacob Campbell.
and we're with Purdue University in New Albany and the College of Technology.
We are going to find the coefficient of static friction using this setup here.
And we constructed this mechanism, and it acted as a variable speed turntable. We controlled the spinning speed by the air pressure going to a pneumatic drill. The tachometer was used to measure the tangential velocity at this location on the spinning wheel.
We have three items that we will be testing: an aluminum bar, a square acrylic piece, an aluminum puck. And we have two different surfaces we will be testing: the slick turntable surface and the non-slick pad that we have here. And the test will be performed at different distances from the center.
When an object is moving in a circular path, it has a velocity that is tangent to its path and a normal acceleration which is always directed towards the center.
To understand this more, we begin by finding the object's velocity from the tachometer reading. We first multiply the reading by the ratio of the two radiuses of the rotating wheels. This gives us the tangential velocity where the spinning tachometer meets the tabletop. We then multiply that velocity by the ratio of the object's distance from the center and the distance from the center of the known velocity.
After finding the object's velocity, the normal acceleration can then be calculated using the equation AN equals VT squared over rho, where rho is the object's distance from the center.
Drawing a free body diagram of our object and doing a summation of forces in the x direction reveals how the coefficient of static friction and normal acceleration are related. As the equation shows, the mass cancels out, leaving only acceleration and gravity. This tells us that the coefficient of friction is purely a material property and has nothing to do with the mass of the test objects.
In this data table, we see the influence that the non-slick surface has on the coefficient of friction. Notice that the mass has no effect on the friction coefficient.
In the video, it was proven that regardless of mass and distance from the center, the friction coefficient is based on material properties.
So thank you all for watching our video, and I hope you learned something.